Hello and welcome to Unstress, the summer series for 2021. What a year 2020 has been, and we have curated some episodes which we think were particularly relevant to what has been going on. I hope you're having a great break, looking forward to the new year and catching up then. Until then, hope you enjoy this episode. Hello and welcome to Unstress. I'm Dr. Ron Ehrlich. Remember the food pyramid? It was endorsed by almost every government and every health authority, with grains as the foundation. It was developed in the 1980s, endorsed by the FDA in 1992. Then, shortly after that, heart foundations and diabetes associations and medical associations around the world, certainly in the USA, UK and Australia. It morphed into My Food Plate in 2005 and more recently in Australia in 2013 into Australian Healthy Eating Guidelines, which actually looked very similar to the plate in the pyramid. It also suggested that 3 meals a day was important to maintain blood sugar levels, and if you were on a carbohydrate-based diet, particularly if you also followed the low-fat advice that had literally been shoved down our throats for the last 40 or 50 years, then you really would need at least 3 meals a day. In fact, you could be excused for thinking that carbohydrates are an essential nutrient, but you might be surprised to learn that they are not. Glucose, which is what carbs gets quickly broken down to, is not the only fuel the body uses. The body can also use fat in the form of ketones, also referred to as ketogenesis. Interestingly, cancer cells love glucose and hate ketones. Glucose is very unstable and can cause damage to our human cells. It's why diabetes is such a problem. Glucose out of control, damaging cells throughout the body. The issue of how cells get their energy is a really important one. My guest today is Professor Dominic D'Agostino, an assistant professor at the University of South Florida College of Medicine, Molecular Pharmacology and Physiology, where he develops and tests metabolic therapies, including alternative energy sources and ketogenic agents for neurological disorders, like epilepsy, as well as cancer and wound healing. He's developed an approach for metabolically starving cancer cells through diet and compressed oxygen. So we do talk about breathing, replacing chemotherapy, surgery, or radiation. It's a fascinating conversation, and while the first part of our discussion, it gets a bit technical when Dom is basically referring to parts of the brain that are involved in breathing regulation. So don't get too worried about those details. And for those that really want to explore the neuroanatomy he refers to, we'll have links to an anatomy textbook referencing the brainstem. Getting the balance right of how we fuel our bodies is critical to preventing diseases, and as it turns out, holds great promise for dealing with many conditions, neurological ones like epilepsy, dementia, which is interestingly now being referred to as type 3 diabetes, as well, of course, as cancer. It's a topic we're going to be exploring in more detail in the coming weeks. I hope you enjoy this conversation I had with Professor Dominic D'Agostino. Welcome to the show, Dom.
Thanks for having me, Ron. Great to be here.
Now, Dom, you were in Australia a few weeks ago, and a lot of excitement there with your presentation. You were talking about ketogenic diets and all this, but I wondered before we got into any of that, whether you could share with us a bit of your own journey.
Yeah, sure. Glad to. My background is in neuroscience. That's what I did my PhD in. I guess maybe taking a step back, as an undergraduate college student, I majored in nutrition. And maybe about a year or two into it, I realized there wasn't a whole lot of jobs I could get in nutrition that I really liked. So I double majored in biology just to have a more of a broad background because I didn't know exactly what I wanted to do. Long story short, as an undergrad, I decided to do some research and joined a lab, and that really interested me in neuroscience. And then I applied for a neuroscience PhD program, and I studied the neural control of autonomic regulation. So how our brain controls our body, our physiology, in particular, our cardiorespiratory sort of activities. And the brainstem mechanisms that do that, in particular, with a big focus on breathing.
On breathing.
And on breathing, yeah.
A favorite topic of this podcast, actually.
Really, yeah.
It is.
So I trained with a lot of really great scientists that laid the foundation of understanding breathing.
Wow. So, I mean, that's interesting. Because we were kind of, I was thinking we were going on a nutrition direction here, but of course they're inseparable, and talk about balancing out body chemistry. Breathing's about it, really, isn't it? It's a really important part of it.
Yeah. Yeah. So I, as a PhD student doing basic science research, I had the great opportunity to do that research in a pulmonary critical care division, a clinical hospital. But so the focus of our lab was understanding the drive to breathe as it pertains to oxygen chemosensitivity. So we classically know the drive to breathe is basically driven by CO2, so CO2 sensitivity. And there's CO2 chemoreceptors that are classically shown to be on the ventral surface of the medulla. But work done in the mid-'80s and '90s showed that these CO2 chemosensitive regions are distributed throughout the medulla, including the nucleus tractus solitarius, the pons, the locus ceruleus. There's many different brainstem areas that actually have these CO2 chemoreceptors. So the field of respiratory neurobiology was kind of changing our understanding that there's multiple centers linked to sympathetic control, and these respiratory centers were juxtaposed to cardiovascular centers, including the C1 sympathoexcitatory region. And that region is in the brain, and it's juxtaposed to the rostral ventral lateral medulla. And that area of neurons has inspiratory neurons and expiratory neurons. And it's kind of a back and forth interplay between the two. So the inspiratory neurons fire, and essentially that causes an inspiration, and then the expiratory neurons fire, and that can help facilitate expiration. So I studied those neurons, and I studied a small area within the rostral ventral lateral medulla that is the respiratory rhythm generator, and that's called the Pre-Botzinger Complex. And that area of the brain is if you make a small ablation and you damage that area, it completely stops. The animal will stop breathing, or we stop breathing. And those particular neurons function as oxygen chemosensors in the brain. And my PhD was focused on studying the oxygen chemosensitivity of those neurons and how they sense oxygen and how that modulates kind of our physiology and how we can modulate that.
And what was the take-home message for the ordinary person who is trying to understand?
Yeah, sure.
Okay, what was the take-home? I mean, PhDs lead you down a rabbit hole, a hole that is so defined. But there must have been a couple of take-home messages for the public. As I say, give us a couple of gems about breathing that you came out of your PhD with.
Yeah, well, I got an appreciation for really how complex breathing is from a neurobiology standpoint, and how it's a real miracle that we don't have to think about breathing, really, that it's an autonomic, but maybe we should. So that brings up another kind of idea, how we can modulate our breathing to control and actually change our CO2 chemosensitivity and even change our oxygen chemosensitivity. So my PhD work was studying an enzyme called heme oxygenase 2, and we determined that enzyme functions as an oxygen sensor in that region. So that was the main finding of my PhD work. And that enzyme is expressed within certain subpopulations of neurons in that area. So some of the maybe broader implications are that it can relate to different things like sudden infant death syndrome. So that area that I studied is implicated in the etiology of sudden infant death syndrome, the Pre-Botzinger Complex, because children or babies will fail to gasp when they are placed on their stomach when they're sleeping, and that particular area triggers the gasping response, and that particular area senses low oxygen, and by sensing low oxygen, it triggers the gasping response. So that's some of the implications of my work were associated with various breathing disorders, but I became kind of more interested in how extreme environments alter those neurons, and also how we can, change, like how those things change with various breathing exercises, with exercise, with changing, brain energy metabolism. I was very interested in lactate. And that put me on a direction of basically studying. I became a very avid diver, and then my postdoctoral fellowship was basically doing some research, developing techniques to understand the neurobiology of breathing and brain energy metabolism under these extreme environments of high CO2, low oxygen, high oxygen, that would be experienced in, for example, military personnel or even astronauts, and that became the direction, the trajectory of my postdoctoral fellowship.
Wow, you'd be very familiar, I'm sure, with Wim Hof. We touched on his. Yeah, and I mean he really plays around with breathing and placing the body in various states of acidosis and playing around with that acid-base balance, doesn't he? Is that what he's doing in his almost hyperventilative state?
He does. He has a pretty interesting protocol that he's kind of developed through his own methodology, and we actually have an ethics protocol, an experimental protocol approved by our university, where we're going to, hopefully, if everything works out, go to Kilimanjaro and do some studies with Wim and his team up there. So he's got an interesting protocol that he uses. I'm also interested in Buteyko breathing.
Yeah,
you may have heard of
very well.
Buteyko breathing.
Yes, very well. Yes, well, their focus is very much on that end-tidal CO2.
That's right.
And controlling breathing, and I'm very familiar with that. And also, had you found much relevance between mouth breathing and nasal breathing?
Yeah, I do. I tape my mouth.
Me too. It's like a sect, isn't it? Really, when you tell people, it's.
I know. So I can tell you, and you won't judge me. So
no, I won't.
That's a good thing. But we do a lot of research with NASA, and part of the research that we do is sleep, and we look at stress, we look at microbiome and cognitive function, all these things. So I'm continuing to monitor my sleep. I was a crew member on a NASA analog mission, and I kind of collected data, and I'm still continuing to collect data on that, and try different things to determine how it affects my sleep. And I did. I think I'm a nose breather anyway when I sleep for most of the time, I think. But I did wear the tape for, I guess it was a 2-week period, and I did get exceptionally good sleep. But I happened to be home. Things were a little bit more calm, and then it picked up over the last month. I have not been taping, but I've also been kind of comparing nights when I wear tape and don't wear tape.
And what have you come up with? What are the big differences?
Well, if I look at all the data when I was wearing the tape, my ratio of deep sleep was more, and that could be perhaps I have to do it when I have a block of time when I'm home, and I do like 1 week and then the next week with and without tape. So my schedule is kind of, I'm crossing time zones. When I flew to Australia, I was about 36 hours without sleep because I don't really sleep well on a plane, and I just worked and then got back on the plane again. My life has kind of been like that. And I think my nutrition and some things maybe I'll talk about later can help with that stress resilience. So I tend to maintain, good cognitive resilience and kind of keep my wits about me just for some of the nutritional things that I do. But I think breathing plays a huge role, and it's one of those understudied things. So just like I studied nutrition when I was an undergrad, and it was kind of cool, to full circle to come back to nutrition. And for neuroscience, my PhD work was breathing and neural control breathing, and I feel like I want to bring that back into my research program. And I studied it. I literally recorded from neurons in the brain. It's a technique called patch clamp electrophysiology. That's what I did in my PhD. But I would like to do it more from a sort of a systems respiratory physiology perspective.
Yeah. Well, that the breathing is music to our ears, but then it brought you back to nutrition. So you've done a kind of a full circle.
Yeah, and nutrition impacts respiration. So what we find is that our sort of O2 consumption and CO2 production appears to be more efficient. When we're in a state of nutritional ketosis, we don't produce as much CO2, for example, when we're burning fat instead of carbohydrates. So it tends to give off a little more CO2. So these are things of interest to military personnel that live in a submarine or in a space habitat, because the CO2 burden of the space environment is something that needs to be dealt with by various methods.
Now, Dom, back onto where we were. This has been fascinating. We've been talking about breathing like this. It's fabulous. But we hear a lot about different kind of diets. Paleo, ancestral, low carb, high protein, Atkins. Ketogenic is a kind of word that's cropping up a lot nowadays. Yeah. Can you tell us what is the ketogenic approach to diet?
Yeah, so the ketogenic is a bit of a buzzword now, but it's been around for a long time, nearly just about 100 years. It was used clinically. The Mayo Clinic here in the United States developed the protocol when they realized that fasting, it was observed, prior to the ketogenic diet, that fasting was a means to control seizures. But you can't fast someone all the time, right? You have to feed them at some point. So it was observed that if you fed someone a diet that was primarily fat, and you adjusted the ratios of protein, so you gave just enough protein to prevent protein malnutrition, that person would appear to be in a fasted state. So it would mimic the metabolic physiology, we would say, of fasting, meaning that the ketone bodies would be elevated, and then the hormone insulin also would be suppressed, and the blood glucose would be sort of suppressed too.
Can we just take a step back from this for one moment? Because I'm familiar with the term, but we could almost be excused for thinking that glucose is the only fuel our body can take or we need, and there's lots of reasons why we think that's dogma now, but that's not the case. So can we take a sort of a step back and just say ketones? What are the ketones?
Yeah, so from an evolutionary perspective, even kind of taking a bigger step back, in the absence of food, we store maybe about 2,000 calories in carbohydrates in the form of glycogen. And even a lean person stores about 20 or 30,000 calories in the form of fat. Right? When we stop eating, within about 24 to 36 hours, we metabolize all of our carbohydrate stores. So we start liberating, and our brain, is using that carbohydrate to make glucose. And we liberate fat from our adipose tissue for energy, but the fat doesn't really cross the blood-brain barrier very well. So the fatty acid oxidation in the fat-burning process in the liver makes these ketone bodies, which are water-soluble forms of fat molecules. They're smaller chain carbon molecules that can readily cross the blood-brain barrier. So our body converts the fat to these ketones, and then these ketones largely replace glucose as the primary source of energy in the brain. And after about a week of fasting, nearly 70% of the brain energy metabolism is derived from these ketones. And we did not know this until about 1967, when George Cahill did some studies at Harvard Medical School with Oliver Owen, a researcher resident in his lab, made this observation. It was published in 1967, and they looked at the blood flow going to the brain and coming away from the brain, and they did some fairly elegant metabolic, biochemistry at the time, and determined that ketones were really fueling the brain in a fasted state. They fasted subjects for 40 days in that particular study that was published, and not something that you could really pass, that would pass the ethics board today. So, but it changed the way we think about brain energy metabolism, because prior to that, it was thought that the brain needed 100% glucose for fuel. So the ketogenic diet then really changes the fuel system of the brain and the entire body. And it also changes the neuropharmacology of the brain. It literally changes some of the neurotransmitter systems that we're looking at, and it alters our physiology and our psychology too. So it even can impact things like stress. So that's my wife is a behavioral neuroscientist, and that's a big part of what she focuses on.
Well, stress is another favourite topic of this podcast as well.
Yeah.
As it is for us all, I guess, not just the podcast. So this was a major change in our thinking. I mean, you're talking about we'll leave aside the 40-day fast, but a 1-week fast, is that what it takes for ketones to kick in? I mean, are we talking about not eating, just on water for a week?
Yeah, well, that particular study that was rather extreme was a 40-day fast. But for the average person, and their ketones got quite high, up to 6, 7, and nearly 8 millimolar, like towards the end there. But and an extension of the study that would not only not pass the ethics review board, but would probably be considered criminal. They injected the subjects with a dose of insulin, about 20 IUs of insulin, and they pushed the glucose down to 1 millimolar per liter, which is about 18 milligrams per deciliter. It's a very small amount of glucose in the blood, and they made the subjects severely hypoglycemic, and the subjects were asymptomatic for hypoglycemia because their ketones were elevated. So it was a further dramatic demonstration that the subjects could keep their wits about them and actually not experience hypoglycemia even at a level of glucose that would typically be fatal for the normal person that did not have ketones in their bloodstream. So it really revolutionized the way that we kind of thought about brain energy metabolism, that there was this alternative energy that existed in our body, that our body could make this alternative energy that could literally fuel our brains under certain conditions. And in this condition, it was prolonged fasting, but that's essentially what the ketogenic diet does. It mimics the metabolic physiology of fasting and elevates those ketone bodies.
Well, the thing that I'm realizing as I'm talking to different practitioners about different conditions, and it doesn't matter whether I'm talking about cancer, cardiovascular disease, autoimmune condition, insulin level seems to be the common denominator, and the higher the worse. So this has huge implications, of course, considering how ubiquitous diseases are. Where do we start on this? I mean, Let's look at cancer, for example. I mean, I know you've done a lot of research on the neuroscience, and we'll talk about these neurological diseases too, but something that's often intrigued me is that we very readily accept these PET scans, which are, tell us what the rationale behind a PET scan is with the radioactive glucose.
Yeah, the PET scan uses something called fluorodeoxyglucose. So it is as you mentioned, a radio-labeled glucose molecule that when it's given into the body, it's a very good indication using positron emission tomography. We can measure the absorption of glucose in the tissues, the utilization of glucose in the tissues. And the PET scan is essentially showing, if we're imaging a tumor or we're imaging the brain, it shows glucose consumption. So in an Alzheimer's disease brain, it shows less fluorescence intensity because in Alzheimer's disease, one of the hallmark characteristics is that there's glucose hypometabolism. So that's why ketones may be able to sort of rescue some of the brain cells by giving an alternative energy substrate.
I've heard that dementia is often described as type 3 diabetes.
That's right. Yeah, it is insulin resistance in the brain. So the brain can actually make insulin too. So it's this is kind of new information that's coming out, and there's quite a bit of interest in that and studying that type 3 diabetes in the brain. So cancer, on the other end, is when a normal cell transforms into a cancer cell and becomes neoplastic, the oncogenes, so genes that cause cancer, are activated. And there's a number of sort of provocative agents that can transform a normal cell into a cancer cell. It could be a virus. It could be a carcinogenic chemical. It could be radiation, inflammation. So, chronic inflammation in tissues like the liver, for example, can transform normal liver cells to cancer cells. And when a normal cell transforms into a cancer cell, a number of genes are activated. And these genes, when they're activated, the cancer cells transform into a type of cell that has a classical hallmarks, and we call that the hallmarks of cancer, right? They have increased angiogenesis, increased inflammation, increased proliferation, and all these things, and there's very high glycolytic rates of cancer cells, about up to 200 times higher than normal cells. And the PET scan is used to basically identify the location and the aggressiveness of cancer by the fluorescence intensity of the tissue, as indicated by the glucose consumption of the tissue. So the higher the glucose consumption, the more it's going to be concentrated in that tissue. And cancer concentrates it very high because it has a very high amount of insulin receptors, of the GLUT1 transporter, which is the transporter for glucose. And it's essentially starving the surrounding healthy tissue of glucose by sucking up all the glucose itself for its metabolic needs, but also the expanding biomass, because the cells are replicating and they tend to use a lot of glucose and they use a lot of glutamine.
This is what intrigues me about our modern approach to this problem of cancer. We very, very readily accept the diagnostic value of this thirst for glucose, but we haven't quite translated that to a treatment, approach. Now, that speaks to a sort of a different philosophical view of what the origin of cancer is, isn't it, really? I mean, there are two ways of looking at it.
Yeah, and I was really, as a neuroscientist, going into the field of cancer a little over 10 years ago, when we made some observations, and I was trying to understand them because I just started studying a cancer cell line and just as a side project. And I started looking into this more, and I knew about a PET scan, a PET CT scan. It was sort of the gold standard to really identify the location and aggressiveness of tumors. But that information was not used by the oncologist to target it. And in 2008. There really was no tumor metabolism conferences. There was no cancer metabolism. Now there's quite a few of them. There's a bunch of them. In 2011, they were very resistant to do this because the hallmarks of cancer was written by sort of genetic centric scientists. But in 2011, they added a metabolic dysregulation to the hallmarks of cancer. Even, many decades after Otto Warburg had showed this, and there's sort of political reasons for that and various reasons. But they added, metabolic dysregulation and high glycolytic activity essentially to one of to the hallmarks of cancer. So now, only many decades after what Otto Warburg observed, now you have almost all these scientists jumping on the bandwagon and just studying cancer metabolism. And one of the bigger conferences was the Keystone Tumor Metabolism Conference, where Lou Cantley, who's one of the top cancer scientists of the world, gave the keynote talk. And part of his keynote talk was about the ketogenic diet. He said that he personally follows the ketogenic diet. And his study, he uses a drug to target a glycolytic pathways, the PI3 kinase pathway. And in his most recent data, the drug doesn't work unless the patients are on the ketogenic diet to suppress the hormone insulin. So it only works and so that was kind of, we've come that far, to the point where they didn't even recognize the diet as a valid therapy, to where it's now part of keynote talks in the major conferences.
Well, can you just give us a sort of a 101 metabolic, that it's not a genetic disorder, but it's a metabolic disorder? What is, in very simple terms, what is the rationale behind this metabolic approach?
Yeah, so the idea that Otto Warburg advanced through his work on cancer metabolism, and part of him receiving the Nobel Prize was this work that he did on metabolism, on cancer metabolism, and his work basically showed that damage to respiration and so mitochondria, right? Mitochondria make our ATP, our energy currency, through respiration, and the mitochondria are the powerhouse of the cell. And outside of the mitochondria, we can do sugar metabolism in the form of glycolysis. It's like a primitive form of deriving ATP energy. And what Otto Warburg has observed was that damaged respiration or damaged mitochondria basically triggers compensatory fermentation, or glycolysis in cells. So the mitochondria, many cells are chock full of mitochondria, and as we progressively damage them, the same things that cause cancer that I mentioned, radiation, chemicals, inflammation, tend to be very damaging to the mitochondria. The mitochondria have their own DNA, but they don't have the robust DNA repair mechanisms that are happen in the nucleus, right? The nucleus of the cell has very robust DNA repair mechanisms. So when you bombard a cell with various toxins and radiation and chemicals from the environment, it tends to damage the DNA of the mitochondria more. And progressive damage to the mitochondria will decrease their ability to make energy in the form of ATP. And then the nucleus will sense that. The nucleus will sense there's an energy crisis. And when the nucleus is the brain of the cell, senses the energy crisis, it kicks on sort of a constellation of oncogenes, various gene pathways that can endow the cell with various proliferative capacity and essentially all the hallmarks of cancer as a normal cell progressively. And it's not an immediate switch, but as these oncogenes are activated, this initiates the transformation of a normal cell to a cancer cell. And essentially what that means is that damaged mitochondria and the ketones are metabolized exclusively in the mitochondria. So as they become progressively damaged, the cell reverts back to sugar metabolism. So a super aggressive cancer that's proliferating very rapidly will depend almost exclusively off sugar metabolism because the mitochondria will be so damaged. And that prevents that very same cancer cell from using ketones as an energy source, because if the mitochondria are damaged and the cell has reverted entirely to glucose metabolism and to some extent glutamine metabolism, it cannot effectively use ketones as an energy source. So that becomes sort of an underlying rationale for using the ketogenic diet too. It's part of it.
Yeah, well, that's rolls off the tongue very easily, but that's huge, really, isn't it? I mean,
yeah.
Oh, yeah. Okay. Well, that's interesting. Let's move on and find out what chemotherapies we should be. I mean, maybe we could just stop feeding the cancer cells.
Yeah. So that's the obvious thing, right?
It would be.
That's the obvious thing. It's kind of unfortunate that the molecular biology really was advancing very fast and started in the 70s and then the 80s, and that the whole culture really influenced the track that cancer research went down and where the funding. So that's really what it comes down to, where the funding was allocated towards. And Travis Christofferson has a great book that really tackles all this. And I wrote the foreword to the book. It's called Tripping Over the Truth. Yeah. And unlike my colleague wrote the book, Cancer as a Metabolic Disease, Tom Seyfried,
yep.
And it's very technical, and that's great if you like technical. But if you want like a compelling, engaging narrative of cancer as a metabolic disease, Tripping Over the Truth, I think, is fantastic. And when Travis asked me to write the foreword to it, I was very intimidated because he's such a good writer. But I did my best in kind of summarizing, sort of why our research went down that path, in the foreword.
Well, it's probably worth reminding our listener that Otto Warburger did his research in about the 1930s, wasn't it? When did he get there? Yeah. So this isn't new research. This is just research that may have not gained the recognition it deserved.
Yeah.
Oh, absolutely. That's a whole political story, isn't it? I mean, people don't often relate politics to health, but gee, there is there. But now let's you did your PhD in neuroscience, and there are lots of neurological diseases that are affected. Can you just give our listener a little bit of a background as to some of the neurological diseases that you kind of looked at in this work?
Mm-hmm. Yeah. So I was funded by the Office of Navy Research here in my postdoctoral fellowship, and that research was focused on something very esoteric. It was central nervous system oxygen toxicity, and that's a limitation for our Navy SEALs who use a closed-circuit rebreather in their diving operations. So, something you'd only experience. Are seizures that you'd experience breathing high oxygen in an operational setting. In the process of studying this, we made the observation that when you induce nutritional ketosis, it makes the brain much more resilient against oxidative stress, and it basically supercharges the brain in a way that if you throw toxins, if you throw high oxygen and various things, it allows the brain to function so efficiently that it prevents it from triggering seizures under conditions that it would otherwise have a seizure. So I realized that this had major implications for other neurological diseases, especially epilepsy, right? Because I started studying nutritional ketosis for oxygen toxicity seizures because the ketogenic diet was used for drug-resistant epilepsy. So now we're studying things, Alzheimer's disease, something called Angelman syndrome. We do work on ALS. My colleagues study autism, which is also associated, with brain energy metabolism. We are looking at, we've done research on wound healing, showing that there's an increase in blood flow to the wound. And there's also an increase in brain blood flow that, people have shown previously. So we're studying glucose transporter type 1 deficiency syndrome, a lot of rare disorders that you may have not heard of. Kabuki syndrome is something that I had that's a rare genetic disease that it causes a metabolic dysregulation in the brain, and there's literally no therapy for it, but the children or adults that have this are very responsive to the ketogenic diet because the ketogenic diet, for reasons we don't fully understand yet, it helps bring the brain back to metabolic homeostasis. It helps to correct sort of the aberrant activity. Even in the presence of a persistent molecular pathology, it can almost silence some of the symptoms of the disease just by restoring, normal brain activity through nutrition. It's kind of amazing that it can do that. So it doesn't always, it doesn't cure it, but it can silence many of the symptoms of, for example, Angelman syndrome, the seizures that kids have, and they also have impairment of motor function, and it improves that too, but it can control the seizures. So when there's no therapies, it's amazing that a diet can, you can use a diet and it works better than any drugs that we have out there for many of these diseases.
I mean, you've mentioned a lot of different diseases there, but two stand out for me, and they're kind of at opposite ends of life's journey, I guess. And one is dementia and the other is autism. Given your research, as you reflect back on the trends, which are kind of frightening, for both of those conditions, what do you look at? What do you think is going on there? Why are we seeing such a rise in these conditions?
Yeah, a good friend and colleague of mine in Puerto Rico, that's what his major focus on. He just had a big autism conference, had about 200 people there, because there's quite a lot of there's a spike in autism in Puerto Rico in certain areas. So it could be environmental. It could be an interaction of, a lifestyle with the environment, with, genetics too definitely play a role in some cases. But it's likely that in many children that have autism, there's a gene that is activated in some kids, and in others, that gene stays dormant. So there's something in our food, there's something in our maybe daily activity or our environment that's activating an otherwise dormant, a gene that stayed otherwise dormant, for most. So it's not likely that we're changing. There's definitely a lot of people studying autism are looking at the genes, but our genomes did not change that fast. We don't have a germline shift, in that fast. So something in the environment is triggering it. Yeah.
And are you seeing good? You're saying that the ketogenic approach is a good way of controlling or slowing down, not necessarily curing. Curing's a big word. But controlling, slowing down, what word would we use for things like dementia or autism? Have we seen positive response to this ketogenic approach?
Yeah, absolutely. I do get contacted by a number of parents that have kids that have autism, and in many cases, it's been sort of the one thing that stands out that has helped. And you can also go on PubMed and find case reports and studies now where they have demonstrated this with the ketogenic diet. The first study, it wasn't a study, it was a case report that was presented at a conference, and 2018, maybe in 2010, where they showed a video of a child that was severely autistic before and after the ketogenic diet, and the title of the presentation was quite compelling, so I had to go to it. I had something else I wanted to see at the time, but I left that and went to this, and it was like the ketogenic diet, puts a child into remission, and it was a casein-free, so a dairy-free ketogenic diet, and it had a remarkable effect. And a year or two after that, then it was on PubMed, so they published it as a case report. And now there's a number of clinical trials that are being done. My colleague Susan Massino at Trinity College has published some work in this, and Jung Rowe, he's the director or chair of pediatric division in Calgary. He has a number of researchers working on the mouse models of this that seem to recapitulate many of the symptoms in mouse models, and they're looking at that. So there's some preclinical work, mechanistically being done to determine why the diet's working, almost working backwards. But at the same time, there's various clinical trials that have started and are ongoing. And many of these trials, you need a couple years to really fully assess sort of the effects. And then you have the question, what is the optimal ketogenic diet? There's many forms of the ketogenic diet.
Was actually going to be my next question, Dom, which was let's get down to a nut and bolt and say, well, what is it? I mean, what is our carbo? How do you measure your carbohydrate? What is it? What is it in real terms?
Sure. Yeah.
What did you have for breakfast this morning?
So the ketogenic diet is much different than other diets because it has a very objective sort of criteria. A ketogenic diet elevates your ketone levels. So if someone says they're following a ketogenic diet, but they're not measuring ketone levels, or they haven't confirmed a state of nutritional ketosis, then I would say they're not following a ketogenic diet. So that clinically, it's defined by an elevation of ketones. And to achieve that, what you have to do is use from a medical sense, it needs to be a fairly specific macronutrient ratio of fats to proteins to carbohydrates. And so the classical ketogenic diet is about 85% fat, and let's say about 10 to 12% protein, with a very minimal amount of carbohydrates in the form of non-starch, non-sugar carbohydrates, so fibrous vegetables, usually green vegetables.
Yep.
And that's the classical ketogenic diet. In adults, they use what's called the modified ketogenic diet, which is a little bit more liberal in protein. So it's like 20 to 25% protein, and the rest basically fat. And you do get some adults can get up to 10% of their calories from carbohydrates in the form of non-fiber or fibrous carbohydrates. So no starch, no sugar, and salads, green vegetables, asparagus, cauliflower is okay, broccoli, those kinds of things, nuts, avocado. But it really comes down to the macronutrient ratio. So theoretically, you could have any food. I mean, you could have pure sugar. It just needs to be you need to adhere to the macronutrient ratios, and you stick to those ratios. You calculate it. You measure it out. Eat it and stick to it, and your body goes into a state of ketosis.
So are you following a ketogenic diet?
I got interested in kind of understanding, what it would be like to be in a state of ketosis when I started studying this in 2008 or 8 or 9. So I bought a book by Eric Kossoff at Johns Hopkins, which was the medical version of the ketogenic diet. And I bought a scale, and I weighed everything out, and I was eating butter and heavy cream, and I found it to be in the beginning I'm pretty strict. Like I can pretty much tolerate anything. And I found it to be a bit challenging, and it gave me insight in understanding what the parents go through when they have to give this to their kids and even adults. And then shortly after I started doing this, the next book, Eric Kossoff's next book came out, and it was talking about the modified ketogenic diet. And then instead of 12% protein, it was like, oh, I could have 20 or even almost 30% protein. And then the diet became much easier for me to follow. I started studying, or I started literally just checking that. I bought all the supplies. We were using it in the lab at the time to measure it in mice and rats, but I would do it myself for maybe about 3 or 4 weeks. And then kind of go back to just like a paleo. I was kind of interested in the paleo diet at the time, but it was like low carb paleo. Then I would switch to the ketogenic diet, and test different things. I got interested in medium chain triglycerides and coconut oil. So I was, I would do the diet with and without MCTs to see that effect. And then I started getting more into the ketone supplements too, and the ketone esters. And we were developing those. So I was testing myself, with and without, the ketone esters. So I've been a constant experiment myself, but at the same time, we're running experiments in the lab day in and day out, and then I go home and I continue the experiments on myself. So it's kind of fun. I like doing it.
And you mentioned that the ketogenic diet mimics fasting, but what about fasting?
Yeah, it mimics fasting in that, so if you're on a ketogenic diet and you're adhering to it as medically you're supposed to do, and you were to pull blood from a person, if I was to take your blood, if you're on a ketogenic diet, and look at the major metabolites and hormones. So if I measured your ketones, I see your ketones are up, and that occurs when you're fasting. And then your blood glucose would likely be lower, and then your insulin levels would also be lower. Lower than normal. I measure my insulin quite often, and it's usually on the very low end of the normal range. It's in the what would be considered the healthy range. It's just in the low end of normal. It's somewhere around like 2 or maybe 3, and with the scale being 2 to 10 or something. So this is an indication that your body's using fat for energy. It's also, these are things that are dysregulated in people that have like obesity and type 2 diabetes. So it's pushing things in, and you could say type 2 diabetes is carbohydrate intolerance, right? So as I started, researching this, it became kind of quite obvious to me. There wasn't a whole lot of research, at the time. Dr. Atkins did some research, but that diet was really what I would call not the healthiest ketogenic diet. I think we have a more of an appreciation for nutrition now, and how you can formulate the diet in ways that can kind of be more healthy. But it did occur to me that maybe the low-hanging fruit was the big issue that, at least in America, maybe in Australia to some extent too, but in America, there was just, 10, 12 years ago, the skyrocketing obesity and type 2 diabetes problem. And it seemed like that was a problem of carbohydrate intolerance. And it seemed like the ketogenic diet, or at least carbohydrate restriction, was a solution to that.
Yeah. Well, if we were to take a step back from, I think if people have got a neurological condition or they're wanting to go on to that ketogenic diet, it's very challenging, and it's an interesting social experiment as well, really, isn't it? Talk about isolating yourself, but if we wanted to, with everything we've learnt, or you've learnt about ketogenic diets and fasting and blood sugars and breathing, what would be 2 or 3 or more tips that you might leave our listener with? They were thinking, wow, this is something I really need to explore. What are the lessons that you'd like to share with our listener? A couple of them.
Yeah, well, I learned that I never thought that I would be, following the ketogenic diet as a lifestyle. When someone mentioned the ketogenic diet to me 15 years ago, I had a very negative view of it. It just seemed very unnatural. Whereas I think being in a state of ketosis it's actually pretty natural, maybe not to be continuously in it, but I think it's very unnatural never to get in a state of ketosis. I think we can all agree that, early humans had limited food availability periodically. So I think, occasionally doing something like intermittent fasting provides some benefits. Intermittent fasting was not something I did years ago, but over the last 2 or 3 years, I've incorporated it into my lifestyle. But I don't do it every day. I maybe do it 2 or 3 times a day. But what I do personally, and what I think maybe others may benefit from, is that I do a low carb, modified ketogenic diet combined with intermittent fasting, meaning that if doing another term for intermittent fasting is time restricted eating, right? So essentially, if I ate dinner a while back. For me, it's like 8 o'clock, 8 p.m., and I will not eat again maybe until 2 p.m. tomorrow. Tomorrow I'm going to do an intermittent fasting day, and that would be 18 hours, right, without eating. And my first meal would probably be a high fat meal. I might have a ketone supplement, or I might have just a ketogenic meal, so I can continue to sort of stay in a state of ketosis, because I know I'll be kind of doing some academic work, or be pretty busy at work at that time. And I can sort of benefit and stay in this mild state of ketosis all the time. And I think that has real world benefits, because you are transitioning your body to be fat and keto adapted. And when you do that, it enhances your mitochondrial health, your mitochondrial biogenesis. Our body makes more mitochondria, and it has a lot of benefits as far as inflammation too. Being in a state of ketosis tends to suppress systemic inflammation in our body, which is a driver for many of the age-related chronic diseases. If I have to say the most beneficial thing that I've seen come out of being in a state of ketosis is a suppression of inflammation in my body. And I measure things like C-reactive protein, and we do cytokine profiles and things like that. And I've tracked all these things for years. And that's been the biggest sort of what I think could be possibly the biggest biomarker is that suppression of inflammation. And everybody seems to experience that to some extent usually. And that can be very beneficial. And there's different ways to sort of implement sort of this metabolic therapy. You could do periodic intermittent fasting. You could do just carbohydrate restriction, not necessarily the ketogenic diet, or just periodically do the ketogenic diet. Whether you should be on the ketogenic diet all the time, probably not. But I would say consider it, unless you're metabolically managing something like cancer or epilepsy or other things that are, clinically responsive to the ketogenic diet. But I do consider it a tool in the toolbox that a normal healthy person can periodically do the ketogenic diet and get some metabolic benefits and health benefits from it.
Wow, that's brilliant. And just on that, because we do hear a lot about low carb. What does low carb mean to you? Grams per day.
Yeah, grams per day. So it depends. So low carb. Some of the athletes that I talk to have such a high output that they're working 5-6 hours a day, like on the bike or running or swimming. So their low carb is like 250 grams of carbs a day or 300 grams of carbs a day sometimes. But my low carb, I'm like I'm behind a desk a lot of time, just working or in the lab and not too active. Occasionally I try to get to the gym or whatever. And for me, low carb is under 100 grams a day of fibrous carbohydrates. And that's very doable for most people. And on the days, and I rarely get that high. Typically, most days I'm 50 grams of carbs or less, and that's from salads. I have salad every day, asparagus, broccoli. I make what's called a cauliflower mash, so it resembles mashed potatoes, but asparagus, Brussels sprouts, kale, spinach. These are all the foods that are in the shopping cart, and I try to source things out locally. Try to visit some of the local farms. I love broccoli though, so I'm eating a lot of broccoli, asparagus, cauliflower, and salads. So make a big part, and avocado to have one every day probably.
And fats, good fats.
Yeah, good fats. I do. Macadamia nuts are very ketogenic food. They actually have a perfect ketogenic ratio, so they can be eaten just as whole nuts. You can put them in a good high power food processor and quickly make macadamia nut butter, which is really good, especially if you're like hiking or camping, and put some of that into like a jar or like a little Ziploc bag or something like that. It's like a lot of calories and a little bit of space and a lot of nutrition. And then I actually have the opportunity to test a lot of the new ketogenic foods that are coming on the market. Like I have ketogenic cookies, ketogenic brownies. I got low carb pasta that's made with like almond flour and stuff. I have to try that this week. So I'm lucky to try that. So these foods didn't exist a few years ago, and they can make following low carb or even following ketogenic a reality much easier, because there's some comfort foods that a lot of people don't want to go without. But I think new creative recipes are allowing people to, and I actually test them. So I don't let these companies off the hook. Like if it doesn't work, about 60 to 70% of the foods people send me don't work, but the ones that work, I'll plug them. I'll put them on my website. I'll literally check the ketones over time. And if it kicks me out of ketosis, I'll let the company know. You got to go back to the drawing board.
Why doesn't that surprise me, Dom? Having just listened to you, I could just love to see your restaurant. If you were doing a restaurant review, it would be a biochemical analysis of everything we've eaten. But listen, one last thing I wanted to ask you, taking a step back from all of this, and just observing as an observer of life and a participant in it, what do you think our greatest challenge for individuals is as we journey through life in this modern world? What do you on our health journey? What do you think the greatest challenge is?
I do think it is stress. My sister, I just saw, I didn't even know it at the time, but I saw my sister post on Facebook that she's going back to school. She's a nurse practitioner, and she sees so many patients that are depressed, and it's from anxiety and stress. And I know your podcast is about stress, and being in the world of academia, there's a lot of pressures in academia. And I faced stress along the way many times. And there's a couple things that I really need to have in my life to decrease stress. And that's, healthy relationships, my family, my wife, of course, and to have creative downtime every day. No matter what's going on in my life, you need recreational time, you need playtime. Right before I got on this podcast, I take my dogs for a walk and we go running in the park. We'll do some sprints and things like that. And nutrition, of course, I'm all about that, but also sleep. So sleep, relationships, nutrition, and I would say creative downtime. Work, we want to, have a job where that really excites us and everything, but we need to have a life outside of work, and actually schedule in, like look at your calendar, look at your schedule for the day, and actually schedule in that creative downtime, because if I don't do it, it doesn't happen. I get so into my work, and it's a good thing to some extent, but I become very unbalanced and unhappy if I'm all about work. I need to schedule that creative downtime in. So sort of that
Dom, thank you.
Those things right there, but in balance.
That's great, and you've given us so much. Thank you so much for joining us. I've so enjoyed talking to you today.
Mm-hmm. Thanks for having me, Ron. I appreciate it.
Now, if you've been following the podcast, you will know that keeping insulin levels low is the key to cardiovascular health, controlling or avoiding diabetes, almost every autoimmune condition, and of course, cancer. And the best way to do that is to lower your carbohydrate intake and eat healthy fats. Fasting also has an important role to play, and that's another theme we'll be exploring in a lot more detail in the coming weeks. So what is low carb? I think measuring your carbs for a week or two is a great investment in your health, just to get a handle on how much you're actually consuming. Dom mentioned a figure of 100 grams of carbs per day. For example, a medium apple is 21 grams of carb. A banana is 24 grams and one medium-sized potato is 33 grams. So we're already up to 75 grams of carbs per day just there. A slice of bread is 12 grams, so a sandwich, 2 slices of bread, is 24, and bingo, you're up to 100 grams. It doesn't take much. Personally, I try to maintain 70 grams per day. I think that is achievable. I think it is sustainable. I've certainly found it to be like that. Now, when you fast, your body goes through the glucose stored as glycogen very quickly, and after a short while, you might start burning fats. And as Dom mentioned, in human history, it's unnatural for us not to be burning fats. I've been doing, 16-8 or 18-6 for a few months now, and it's really quite easy. That means 16 hours of not eating and 8 during a period of 8 hours where I will have 2 meals, or 18 hours of not eating and 6 hours of eating 2 meals. So, for example, I might eat dinner at 6 or 7, then the next meal in the evening, and then the next meal would be 1 o'clock the next day. So 16 hours of fasting, 16 to 18 hours of fasting, and 6 to 8 hours a period of eating. And I'm also going to be trying fasting for a day or 2 or 3 on a regular basis. As I say, we're going to be exploring that, and I'm reading a lot about the benefits of that, and they can be quite profound. So we'll be exploring fasting and ketosis in more detail in the coming weeks ahead, and the idea that cancer, rather than being a genetic disease, is actually a metabolic disease. Now, that's an important concept because it gives you more power over what you feed or starve your cancer. Food for thought. So, until next time, this is Dr. Ron Ehrlich. Be well. This podcast provides general information and discussion about medicine, health, and related subjects. The content is not intended and should not be construed as medical advice or as a substitute for care by a qualified medical practitioner. If you or any other person has a medical concern, he or she should consult with an appropriately qualified medical practitioner. Guests who speak in this podcast express their own opinions, experiences, and conclusions.